Dear colleagues, my name is Andriy Khizhniak. I am a senior lecturer and researcher from Ukraine. My work focuses on the personalization of practical tasks in IT education, including their automatic generation and verification. With the rise of big data, AI, and machine learning, educational products, especially in IT, have evolved significantly. Practical tasks are central to IT training as they develop skills in programming, network administration, and data analysis. My research focuses on making these tasks more effective through personalization. Today I will present a classification of 9 levels of personalization for practical tasks in IT education and a personalization index for quantitative evaluation. Current approach to personalized and adaptive practical learning are diverse and inconsistent. Authors often define personalization depth differently, and there is no unified scale, terminology, or classification. It is impossible to say that one solution is more personalized, more effective, or more complex in terms of personalization of practical tasks than another, since there are no criteria for such an assessment. This leads to a methodological gap. We cannot compare solution, harmonized standard, or planned system architecture. A generalized classification would provide a scientific tool for analysis, comparison, and improvement. Our research objectives are analyze existing approach and systems for personalization practical tasks in IT education, develop a generalized classification of personalized levels, propose a metric for quantitative assessment of personalization depth. We conducted a systematic literature review with PRISMA guidelines and applied the design science methodology. Our classification is based on 4 analysis layers: conceptual analysis from literature, integrated assessment of our own teaching experience, associative analysis, and empirical analysis from expert discussion. Each iteration refines the levels based on literature, expert input, and real-world system. Prior works systematize personalization by architectural components, environment, content, learner model, or context integration and self-regulation, timescales, macro, meso, micro, parameters, recommendation strategies, and evaluation methods. We refined the classification from initial 7 scale to 9 levels, considering complexity of implementation, impact on learning trajectory, amount of students' data used, motivation impact, adaptivity to learning needs. In proposed classification, level 0 means no personalization, so all students have identical task and there is no difference between them. Level 1 it means some personalization based on login or profile, so each student have own learning space. Examples are profiles in LMS, some like Moodle, Canvas, or others. So standard assignment within LMS. Level 2 is variant-based personalization. Each student receives a unique version of the assignment from a fixed pool. The variants do not significantly affect the solution methodology. Example of usage is randomized assignment of task variants using LMS functionality. Level 3, parameterized personalization. The tasks have the same structure and complexity, but are generated automatically based on variable parameters and initial conditions. Level 4 is knowledge level personalization. They are selected automatically or by teacher according to the student's level of knowledge, based on diagnostic or the result of previous tasks, and based on progress analysis, dynamic complexity. Example of usage: system operating on the following principle: easy task, successful completion, more difficult next task. Level 5, interactive personalization. Completing tasks in an interactive environment with instant feedback and dynamic correction. Adaptation based on real-time response. An example of usage: web platforms, interactive EDS, instant feedback system, AI assistants, etc. Level 6 is learner model-based personalization. On this level, systems should use individual characteristics for deeper personalization. It means that system should adopt into learning style, pace, error, strengths, weaknesses, all this information collected through behavioral or analytical models. An example of usage and machine learning models, neuro-adaptive systems that select the format, formulation, maybe graphic, coded text, number of tasks, number of repetitions, etc. Level 7 is motivational and gamified personalization, using game mechanics to increase motivation and personalization the learning process, focusing on motivation, emotional experience, and encouragement. The example of usage using points, ratings, level, bonuses. Level 8 is context-based personalization. Tasks are adapted to the student's personal interest, specification, or professional content. Increased motivation, immersion is on professional environment. Example of usage, GPT generation, specialized simulation, etc. Level 9, personal cognitive personalization. Deep individualization and adaptation based on learning style, temperament, emotional stage, cognitive characteristics, or psychological data. An example of usage taking into account the cognitive and psychological characteristics of the students using sensory data like pulse, reaction time, etc. to change the type of the tasks. So, our levels progress from simple non-adaptive solutions to complex, high-adaptive and motivational approaches. Higher level require advanced algorithms and deep integration with the learning environment, while lower levels are simpler and more scalable. We validated the classification against recognized scientific criteria: clarity, hierarchy, completeness, exclusivity, and validity. The personalization index is calculated as the normalized weighted sum of the implemented personalization levels, where the weights correspond to the complexity of each level. This approach gives higher weight to more complex and impactful levels. This allows comparison between systems not only by the number of personalization elements, but by their quality. Prospects for further research include experimental verification of the effectiveness of each level, improvement of existing methods and that implement individual classification level, integration of classification into learning analytics systems in IT education, developing a unified information technology that would include support for combined levels of personalization. Also, this classification has certain limitations. It's focused on practical tasks in IT education and requires further validation across the wide range of subject or levels of education. The implementation of higher levels requires complex technical solutions that are not yet widely available. So, this is all from me. Thank you for your attention. Bye bye.